So consider the expression 3n squared plus n plus 2. What is the coefficient of n? So what's the number out front in front of n? What's in front of n? 1. Okay. What terms are being added in the expression? Can we combine anything here? Can we combine anything here?
Absolutely, yes.
So really quick, we have 3n squared plus n plus 2. We know that we can only combine what? Like terms. Are there any like terms? Does everything have an n? No. Okay, so this 3n squared, there's an n squared. Is this n squared? So are those the same thing? No. So can we combine anything? No. So all we're doing is just leaving this alone. Okay? No like terms. So I have any paper? I do not. I'm like out. Okay, look at one of the formulas for perimeter of rectangle where L represents the length and W represents the width. What does the 2 represent in this formula? Yeah, baby. Yeah, so what does that 2 represent? So really quick, if we had a rectangle and you tell me this is length and this is width, and I add this up, why do I have a 2 out front? Multiply it by 2 because there's how many sides? There's 4 sides. So because of the 4 sides, we're going to have to multiply that by 2 because L plus W only does 2 sides. Everybody understand where that's coming from? Okay, again, this is EOC review, so we're trying to make sure that we're good to go for the EOC. That's coming this semester. Okay, go ahead and take a look at this paper right here. You should have picked this up just a second ago. Okay, if you weren't here yesterday, if you'll flip over to the back, so we're starting with problem number 11. If you flip over to the back, this is what we talked about. Okay, we talked about geometric sequences. So the difference between geometric and arithmetic. Okay, so the difference between geometric and arithmetic. Arithmetic is where we're adding each time or subtracting, could be subtracting. Geometric is where we're multiplying each time. Okay, so it's very similar to how we see exponential function. So for instance, are we adding by something each time to get the next number in the sequence? Can I add a number each time to get the next number? No. But can I find a ratio? Maybe. Let's take a look. If I take the second term and divide it by the first, 12 divided by -4, what does that give me? 12 divided by -4 gives me -3. So my ratio is going to be -3. We have to check and make sure it works for, ladies, we have to check and make sure that it works for every single number. So -4 times -3 gave me 12. 12 times -3, does that give me -36? The answer is yes. -36 times -3 gives me 108. So does that work? Yes. So is this geometric? Yes, it's geometric. We found the common ratio. And now we're going to do the explicit formula. Yesterday, we learned about the explicit formula. What that looks like is we have a sub n equals a sub 1 times r raised to the n minus 1. Yes, you'll be given this formula. A sub 1 represents the initial amount. R represents the rate. And n is the term that we're trying to find. So in this instance, our initial value is what? -4. Okay, so we're going to plug in a sub 8 because we're trying to find the 8th term. And we're going to get -4 times our r, which is -3. And we're going to raise it to the 8 minus 1. So all I've done is just plug in numbers. Now I'm going to go into Desmos and I'm going to type it in. Once I get in here, I'm going to say -4. Make sure that you use your parentheses. And that's going to give me -8748. -8748. Yeah. So what was your ratio for this one? How do we find the ratio? We take 12 and we divide it by 3. Take your second term, you divide it by the first. Okay, so this is 4. Now we're going to plug into the explicit formula. That's going to be a sub 8, because we're going to try to find the 8th term. A sub 1 was 3 times 4 raised to the 8 minus 1. I'm going to go into my calculator. And I'm going to type 3 times 4 raised to the 7th power, or 8 minus 1. And so that's going to give me 49152. Questions over that? Okay. One other thing that we went over yesterday, if you missed it, is the recursive formula. Okay, so recursive formula. What that looks like is you say, hey friend, it's going to be a sub n equals r times a sub n minus 1, where a sub 1 equals some number. Okay? Yeah. 9, 8. You're talking about this? That's a sub n? 9, 8. Oh, a sub 8. A sub 8. It's like 9, 8. Ooh. Okay. What type of sequence is this? Okay, so let's think about it. We start off with 5, then we go to 8, and we go to 11. All right, why? It's adding 3. So arithmetic, because we're adding 3. Okay, so write out the sequence using blanks where appropriate. So if we have 5, 8, 11, that would be 14. Okay. If we write the explicit form for arithmetic, just a reminder, arithmetic's explicit form looks like this, where we have a sub n equals a sub 1 plus d times n minus 1. So a sub 1 was our first term, plus our common difference, which is 3. And then we have n minus 1. We could simplify this, and that would give us 5 plus 3n minus 3, which would give us 2 plus 3n. I'll give this. So how far will the patient walk during the 10th week? Okay, so using that explicit formula, we can plug in 10. So we had 2 times 3n, right? I'm sorry, 2 plus 3n. So if we plug 10 in, they would have 32 kilometers. Yeah? Okay. Now write your final answer as a sentence. At the 10th week, they would walk 32 kilometers. A virus reproduces by dividing into 2. And after a certain growth period, it divides into 2 again. As the virus continues to reproduce, it will continue to divide into 2. How many viruses will be in a system with a single virus after 10 divisions? Okay, so is this arithmetic or geometric? Why do you say geometric? Okay, so we're dividing by 2. So write out the sequence using blanks where appropriate. So we started off with how many viruses?
Two.
One virus. Okay, and then when we divide, how many are we going to have? Two. And then how many are we going to have after that? And then how many are we going to have after that? And the next?
16. 32. 64.
Okay.
128.
All right, now we're going to write the explicit formula for this sequence. So remember the explicit form, we're going to have the initial. So we're going to write a sub 1 times r raised to the n minus 1. So what was our initial amount? 1. What was our r? Why are we saying 2 and not 1/2?
Because you're multiplying by 2.
Well, it says that it's dividing into 2, right? But isn't that multiplying by 2? Isn't that the same thing?
I don't know.
Because we're counting how many viruses there will be, right? Okay, so we're gonna say raised to the n minus 1. Okay, take a moment, finish right. So after 10 division, okay, we started off with 1, we're doubling each time, and then we're gonna do 10 minus 1. Okay, so that's gonna give me 2 to the 9th power, which gives me what? Yep, 512 viruses. There you go. So after 10 divisions, there will be 512 viruses. Okay. Questions over that? Hey. Okay. So Sam has purchased $30,000 car for his business. The car depreciates 30% every single year. Depreciation means the value of the car goes down by that percent each year. What will be the value of the car after 5th year? Note that the car is 0 years when it purchased. So the first year is the second entry of the sequence. Okay. So is this sequence arithmetic or geometric? It is geometric. How do we know? Exactly. Okay. So when we do this, we're going to write out the formula. We're going to have 30,000 as our initial. And then we're going to have 1 minus 0.3. And we're going to raise it to the n minus 1. Okay. The reason why we're doing 1 minus 3.3 is because it keeps 70% of its value. Okay. So if we wanted to find the first couple of terms, we would have 30,000. And then if we multiplied it out, we would get 21,000. And then if we did that again, we would get 14,700. Okay.
1 minus 0.3.
Yeah. What? So if we're multiplying by a rate or a percentage or a decimal. Yes, if we're multiplying by it. Now, what will be the value of the car after the 5th year? So we're going to plug in 5. Okay. So when we do that, that's going to give us 0.7 raised to the 4th power. And then we're going to multiply that by 30,000. Yeah, it's 5 minus 1. So I got 7,203. Is that what you got? Check my work, because that might not be right. I do not. Okay, go ahead and skip down to number 4. You're gonna do 4, 5, 6, and 7 on your own. Okay? Yes, go ahead. Okay, you're gonna do 4, 5, 6, and 7.